Assalamu alaikum. Hello everyone. Welcome to our presentation on mining software repository for maintenance insights, which is a part of our software maintenance lab. This project is being presented to our honorable teacher, Ma'am Iftekhar Alam Ifat sir. Our team here. I am MD Alamgir Hassan with along my teammate MD Alamgir Hussain and Shahrukh Devnath. Let us go through the table of contents. Here we will discuss about the introduction, related work, proposed framework, dataset description, performance evaluation. Let's go through the introduction. To begin, software repository mining is the process of analyzing historical data from software repository like GitHub, including commits, issues trackers, and developer communication to extract valuable insight that help improve software maintenance. Maintenance is one of the most expensive phases of the software lifecycle. This technique provides a way to predict and address potential issues, improve code quality, and streamline the development process by identifying recurring bugs, areas of technical debate, and so on. And the importance of repository data in maintenance. Here we discuss about some aspect like code quality inside it include metrics such as code complexity, code churn, and refactoring efforts. And the importance of this is assessed in assessing code quality and identifying the areas that may need refactoring. And then defect tracking, it considered records of reported defects, their resolution, and related discussion like the importance of this defect tracking is facilitates defect tracking, helps in identifying recurring issues and improve debugging. And then the bug reports and fixes. It records the bugs reported, their severity, and the fixes applied. Importance of bug reports that helps in tracking the effectiveness of fixes and identifying patterns in defect. And then the code reviews it includes the feedback and discussion from the code review processes, provides valuable insight into potential issues and improvements in the code base. Next, go through the existing work. There have lot of existing work. We find some uh, like some paper like PyDriller. It is a Python framework for mining software repositories, and the contribution of this paper, it introduced a tools called PyDriller. A tool simplifies the extraction of information from Git repositories such as commit, developers, modification, and deeps and source codes. And then the second paper is title is mining software repository, a comparative analysis. It in this research it presented a comparative analysis of different tools for mining software repositories based on some criteria such as intent, information, presentation, interaction, effectiveness, language dependency, and availability. And the third paper is deep mining of open source software bug repositories. And the contribution of this paper is they proposed utilizing word embedding and deep learning models from mining bugs repositories in order to identify severity classes of newly reported bug. And the fourth paper is evaluating the lifespan of code smells using software repository mining. It introduced semi-automatic code smell evaluation assistant, a tool for analyzing code smells in software projects. And third, our proposed framework. In our proposed framework, we focused on two main things of like code quality metrics extraction and defect prediction. First, we have access the GitHub repository, and then extract code quality metrics like comment and other quality of metrics, and then provide the data to the model to assess the defect of the quality matrices, and then analyzes the result. And this is my part. And the next part we'll discuss. So Thank you.
Thank you. Today I am going to describe what I have done for in this project. So at first I have done the gathering the information or the analysis information of the GitHub repository. For gathering that, I have used some code quality metrics, or I have chosen some code quality metrics which I am going to collect from the GitHub repositories. For that some of the metrics are what I have collected. That's are, so first one is CVO. What is CVO? That is coupling between objects. For example, for a class or a function, then how much dependence class it has. For example, if I have a class A and it is using a function A, for so it is depending on function A, so we can count it as a one. And we have a WMC which is known as, we have measured WMC which is known as weighted method class. What is that? That is the counts the number of a branch instruction in a class. For example, if a number have how much branch instruction it has, that we have counted, and that is depth in identity. Simply it we can count it a class, how many further it has. For example, if we extend class A with class B, so class B have a further, that means class B is extending from A, so it is a further class which is known as class A, so we can count it as at least one. And we then measures RFC, which is a response for a class, how many uh, we measure it by counting the unique method invocation in a class. For example, if we have a class and that is two functions with same name, and that can be happened with method overloading, that is parameter different. And then if both are executing, so we can count it as one, because both are not unique, that are same, almost same, just parameter is different. And then we have also counted lack of questions of methods and calculates LCOM metrics. And we have also counted the total methods, how many number of methods in a classes. And then we have also counted the total number of fields. And then we have counted NOSI. What is that? That is the number of static invocations. That means we have two methods which are static methods, and we have executed those two, so we have NOSI number is 2. And then we have also counted the LOC, which is lines of code, with we used clock library for that. And then we have also counted the return quantity, how many number of return instruction it has. And then we have also counted the quantity of loops, how many number of loops are present in that class. And we have also counted the quantity of comparisons, like that comparisons of variables are, for example, double equal and not equal, and that's what we have counted. And then we have also counted the try-catch quantity, how many try-catch are there in that project. And then we have also counted the parenthesis expressions quantity, and that is the number of expressions inside a parenthesis. And then we have also counted the string letters, mainly strings are wrapped with double quotes, and in Python we can also use single quotes for getting that. And we have also quantity of number. What is that? That is the number, for example, integer data type, long data type, that's we have also counted. And then we have counted the assignments quantity. That means how many data we have assigned in inside of a variable. And then we have also counted the math operations quantity, for example, plus, divide, and minus, that's we have also counted. And then we have also counted the variables quantity. That's the number of quantity, or the quantity of variables we have presented in the class. And we have also counted the max nested block. For example, if in a class have a nested to if block, and another in that class we have another function have three nested if blocks, so we have counted three, because that's the max nested blocks inside that class. And we have also counted the unique words quantity, number of unique words present in that class. So that is what we have measured for our model, and that these metrics we have chosen for this model. So we have written a Python program for to measure all this information. And After running execution, we get this type of CSV file to get all the value. And in Python we have used AST, abstract syntax tree, to iterate through our full code and by gathering this information. So if we go to the our program, and if we uh, just count it, for example, we are going to analysis analysis these repositories. So we can copy our URL, and then we can go to our program, where at first we will run our Python program, and then we need to provide the GitHub URL. And if we give this URL, at first it will fetch the GitHub repositories, and then after fetching it, it will keep this in a temporary variable. And then if we see at first it have shown the how many files are there, languages are there, and the code line of code. We can see we have JSON file, CSS, JavaScript, JSX, Python, and we have also Solidity for our Web3 or blockchain projects. And so these are the number of code, or number of comment, number of blank, number of files, and that's the total number. And we have seen an interesting thing, that is the CSV file, where we have in first column we have the class name, base config user, and we have also measured the for example CBO, what we have previously discussed, that all the information we have gathered here, coupled between object and quantity. And as we can see, we have also analyzed the time to give this information in our model. So this was my part, and I have done these things, and thank you for this all.
Alaikum, I am Mohammad Alamin. As discussed by Saurabh Devnath previously, that we have built an tool that is used for mining software repository. It extract quality matrices from a software repository. Then we are using that extracted matrices to identify if the software has to predict if the software has any defect or not. So to make this prediction model, we have applied this framework where we collected the data set from Kaggle, and then we pre-processed the data for our model training. Then we applied feature selection on the data set to extract most relevant and useful feature to improve accuracy. Then we trained the model using four machine learning algorithm, and then we evaluated its result. So for feature selection, we have applied recursive feature elimination technique. It is a feature selection technique that identifies the most important feature for a machine learning model. So it basically works on a machine learning model. When building a model, it finds which feature was least significant, then it eliminates that feature. In this way, it recursively keeps eliminating least relevant feature for model building. In our case, we have selected top 7 features that are most relevant in our model training, and those feature were CMO, DIT, etc. So the dataset we have used for model training was collected from GitHub, and this dataset contains a total 22 features, and it has 6053 instant, and the class ratio of defect and non-defect software are 50%. The features that are in that dataset are CBC, WMC, DIT, RFC, which are already mentioned by Saurabh Devnath. So I will not further discuss of which they means and what they means. So then we will see the performance evaluation of our models. Before that, I want to show the model, how we build the model. So first we import the dataset that was collected from GitHub repository. Then we perform some basic data analysis, such as if this model contains any if the dataset contains any duplicate data, or it showing correlations among features. Then we also make some plots to understand how the classes are. Like in defect, there are balanced data set, on both has had same amount of data. Then we used bar plot to see if there are any outliers. Then we show how the data distribution were, and then we also performed uh, histogram to see data distributions, and then we used scatter plot to see how their data are being manipulated and where is defected data and where isn't defected data. Then we splitted the data into train and into x and y, which x represents features, independent features, and y represents the class level. And then we perform scaling on the data set. Then we splitted the data set into train test data. Then we performed model evaluation. In the model evaluation, first we use recursive feature elimination to extract top 7 features. Then we use these 7 selected features for model training, and then use this for prediction. So if we see the results, that in random forest we can see it was 67%, in logistic regression the accuracy was 72%, and in extreme gradient boosting classifier the performance was 80%, which was the best performance. In the evaluation matrix form, if we look at the form that in the a graph, then we will see the extreme gradient boosting outperform other machine learning models, and RF random forest and logistic regression had decent amount of performance, but SVM performance weren't that good. So we will only use a model trained by extreme gradient boosting, and this model will be used in the tool for predicting whether the extracted for predicting whether the software has any defect or not based on the extracted information from Git repository. So this was our overall work. Thank you so much.